Oh, well. Now we can start. We're official. Hi, Destiny. It's like we play favorites here. So, nevertheless, I, I'll begin where I begin, and then I'll go through briefly through some of the documents, because once you get to a certain stage, reading syllabi is not there. It's, labs are fairly straightforward. Okay, I mean, it'll be interesting. You guys, since you started micro lab already, some of you, or yet or no? Some, okay. So you guys have Dr. Dress who already started, yeah, and anybody that's more afternoon has Dr. Oh, wait, he's gonna teach you. Okay, just move this away, which this one. So, I mean, when you have one, I don't know what your labs were like last time, we were doing it, with whoever was teaching your labs last time. To me, the labs are mostly about anatomy, and you leave the physiology, as it were, to whatever you're doing in lecture. So frequently I'll ask what they're doing in lecture. So many of you, I don't have any AMT lectures. You know, normally you're starting with, I assume you all start with special senses this first week. So they're doing things like, and they probably do a certain amount of anatomy, you have to. But I would think the focus point would be physiological, you know, opsins and growth opsins and all that. Is that ringing a bell yet? That type of thing. So our focus point is going to be more anatomical. We'll touch on the physiology. To me, lectures the other way around is mostly physiology. We touch on the anatomical. So in the lab, we have at least 2 or 3 dissections, definitely. Probably with any good luck, maybe next week we do the eye dissection. It's good to get our hands into that. To me, that's the best little 20-minute dissection there is. Doing the sheep eye dissection, you really see all the layers very, very well. You certainly will have a hard, I have to go look to see if I've got all the supplies, but we'll get there, and that'll be coming a little bit later. And and there's also potentially we might, almost like it's a demo, you just use a lung type of thing. Those are typically the dissections that are done. And sometimes I may end up jointly, or maybe have maybe 2 groups doing a mammalian dissection. Mammalian is generally, for the longest time, people did cats. Having 2 cats at home, I can't do. He slept with me last night. I feel bad. Since my wife, she usually sleeps on top of my wife, but she's been staying at home. He said, oh, I'm going to cuddle up with you. It's one of those, he said. You know, okay, I got you. But it's just, so I probably do fetal pain. I don't have any allegiance to the fetal pain. We don't have fetal pain at home. So much for that. So no, that's the experimental stuff I anticipate we would do. I don't know if we do anything in the lab other than that. And what I will use, and I'll explain to you at the end, is to do the technology like that. And some of the other instructors don't use the technology. They're welcome to use it. I should really sit down and show them how they can go about using it. But I'll explain it because you can all access it. For you folks, it's less than we're doing my advanced physiology. With you, it's more like so you can see what's going on with it. And it helps us particularly because I like to do a unit with a respiratory unit, pulmonary functions, and electrocardiogram unit. And that's a pretty interesting unit given today, the events that Damar Hamlin just got out of the hospital today. And we have to have the whole sort of alerted people cardiac one. So I thought that would be maybe a bit more topical or relevant. So let me get started with this part. Okay, we're being recorded. Okay, syllabi. So you should have all gotten this. If anybody was a late registrant, just give me a holler. I'll make sure you send it. And what I'm going to try to do is with these recordings is to embed them on the YouTube. I'm doing that for a reason, since I sort of like I'm creating a series of YouTube things which will make it easier for me to track if somebody doesn't get one or there's a problem. So if you're listening to them, and I don't expect everybody to go home and listen to them, But if you listen to them, and every so often, a student will shoot me an email and go, "Hey, I couldn't hear that," or "cut out," that type of thing. The reality is, just like any other semester, we with regard whatever happens, COVID or other infectious disease wise, we play it by ear. Uh, Mask wise, it's your choice. I mean, it was almost intolerable for me. When you get older, those things are really a problem for someone who used to operate on people and would be in masks for hours. So it's amazing how little I could tolerate them, 40 years later. As a resident back 45 years ago, and we were in the operating room all day long. You basically just change masks in between doing procedures. That was about the hell that you're almost in it continuously. Nevertheless, introductory nugget, me, my contact information, best time to find me. I have a little bit of time, 12 to 1 on Mondays, and I have a substantial nugget of time. So most of my office hours in here. If you would prefer to meet, we could almost meet virtually at any time, and we just create a Google Meets or use the existing one and go from there. So if that's a necessary, just holler. We developed it. Dr. Maurer and I, who some of you all have, we developed most of this syllabus ourselves over the years. And so this is typically, we start with peripheral nerves. A lot of you did the cranial nerves. I did it in my lab. For those that had me for AP1 lab, I do it again because I think they're important. And perhaps they're a little more relevant at this one, but I do it again like that. So maybe not next week, so at least tentatively I'm looking at the eye dissection week 3 and a quiz, because by that time we'll have special senses and the cranial nerves done in week 4. And the quiz is objective and maybe 25 questions or so, multiple choice, true, false, that kind of stuff. Scantron style. We'll do that at the start of the lab and then go from there. And so that's kind of, we do that first. There's not a lot to do with endocrine. Endocrine is mostly a physiological. There's a minimal amount of endocrine anatomy, almost none. It's effectively negligible. Here are the half dozen or so endocrine glands. There you go, pituitary, and basically that's about it. Pancreas, thymus, etc., etc. Not a whole lot to discuss about that. There's a lot with cardiovascular. We don't spend a lot of time on the blood, though I don't mind doing some stuff about that. But we do spend a lot of time on the heart, electrocardiograms, all of the blood vessels, both arterial and venous. There's a fair amount of memorization involved in that. That's there. We definitely have the heart dissection. The exam that I do as a midterm is a practical. And basically what I do is we effectively, I don't know how you did your practicals before. We're probably going to play musical chairs. So if you did the bones practical, that's typically what it is. You move from station to station. There's always time to go back and look. I'm not mandatory about that type of thing. It's not like you only have 30 seconds to make a decision and go back. That type of stuff. But I'm not going to put a heart out here for you to look at that smells bad. I just reprint illustrations, and I send you a list of all the illustrations that are likely or potentially going to be on there. So it's just a matter of reviewing those a little bit. So I'm pretty forgiving with this. Here's what I'd say almost every lab. You have to work hard not to get a good grade in lab. You have to put some effort into it. Don't do it. You have to make a concerted effort not to do well in this. Usually that means not showing up. So I'm not recommending that. Respiratory, I do like to spend some time with. This device allows us to do some fun respiratory experiments with effectively what's known as spirometry, which is really very, very interesting, I think. Once we get past that and the lung dissection, then more or less it's more didactic, meaning it's a little bit more of me talking to you with all those things. And usually the final is typically a mixture of practical and written content. So much for that. It's a little different vis-a-vis scaling and things. We have easy for me to say, 2 quizzes, each were valued at 10 points. The exams, the
practical, both the midterm and the final, if you will, 60 points each. You're talking about 1 or 2 paragraph reports for the dissection. Hand them in, you're going to get the points. And just, showing up and let me see your bright smiling faces. Or just, since you're typically not smiling at me. Textbook, which you already know about. I don't use a lab manual. I feel there's enough from the text. The lab manual is really just more from the text. Manuals typically have neat little things like matching and things that you can do, exercises. Some people like those. I am not inclined to those things. I think it's up to you, really, how you're going to prepare for it. I am not homework driven at all. I'm not work product driven. I do a little bit of this here with regard to these small reports, which you could send in electronically or give me a hard copy of. That's fine. And everything else is pretty, like I said, I record all of these things as I'm doing now. The optionality of face masks, how we meet, et cetera, et cetera. And then we get to this iWork system note that I will be demonstrating here in week 1. So much for that. Like I said, there we are recording away. And so where you're going to start to find the material that we're starting with today, and it really what it is over time, I have sort of added to some existing power. So if you're not sure where to find these PowerPoint lecture guides, which have all the illustrations, by the way, I will let you know. So we're starting with peripheral nervous system, which encompasses things like cranial nerves, the peripheral nerves, like the sciatic nerve, the femoral nerve, the radial nerve, musculocutaneous median nerve, the big nerves that are part of the extremities, other than that, spinal nerves, etc. It includes the anatomy of the eye and the ear is the major anatomy. There's not a lot, though I'll comment on things like taste and smell, because they're really just modified chemical sensors. There's not a whole lot of anatomy that I think you have to get into with regard to that. So we're going to find that on PNS, standing for peripheral nervous system, A, B, C, D, and E. But it's not on all. A lot of the material is physiology, because it's incorporated both. So again, our focus will be the anatomy, other than where the physiology is relevant. So you'll find that there. I don't know that I don't think you need to open that particular zip file. I haven't looked at it in a while, so I don't know when I put it on there. So for the Lab Scribe, I went on to their website. A word about this device that's sitting under my lap. This is my regular laptop from here from school. And that's this, and this sort of case that it comes with it. Lab Scribe is a very interesting bit of technology that comes from this company called iWorks. And we purchased it 3 or so years ago. And we're able to we used to try to do these physiological experiments, but we really didn't have a lot of equipment. And so nowadays, it's really like a mini computer, and the software is, when you purchase the system, you get unlimited software downloads. Now, the software you can download yourself, but the only thing that I advise you, and if I did not, I will send you the logon information whenever you don't have to do it this week, because I'll just do a brief demonstration of it, is to utilize, we have basically one university logon. So all that allows you to do is to access the software so you can use that. That's really what it does. So once you have so in order to be able to access it, you need to have some type of identification. I'm the identification. So when I set it up, and I think it was 2019, did I send you the logon stuff or no? Maybe I don't recall, because I sent it to my other one. But it's very straightforward. You're using my email and my logon, which is something like iWorks 2019 with an exclamation point. Nothing really made magic about that, because for a while the students were trying to set up their own, and I'm getting all sorts of notices from the company saying you don't have to do that. Now, on your own computer, you can do whatever you want. On university computers, this software should already be there. Okay. They tell me that they have certain software packages that the tech people have looked at and said is okay. So if you go to the library or the computer lab, I would think you'd be able to do that, and if you're having a problem with it, let me know, and I'll go through the help desk to try to figure out what's going on. Okay? So, but if you're doing it at home, whether you have a Mac system or a Windows system, these are the installer, and they have manuals. Personally, I would do it without the PDFs because you really don't need them as much. You're just really going to look at the data. Well, and we're not getting to that yet, but we will. So that's something you can look for. You just have to go to this. So I went, iWorks Systems Inc. So it's iWorks.com. And you can see all these, and they have all these interesting different features that are there. We're using what's called the teaching assistant one. It's iWorks TA, and that's how you'll be able to recognize. And I'll show you when we start to use this how to go through it. And then basically acquire, and then you just have to click on either here for the software, or you can go backwards and find it. I suspect that will probably take you right to that software thing. Make me look good here. Thank you. Minimum requirements, log on and download, whatever, that type of thing. So you'll be able to see this, and they give you all the ways of accessing it, which I will go into, not having a lot of expertise in that. Okay. So what I will start to do is with these recordings, I'll probably let you know when I put them on, because we're dealing with a peripheral nervous system. It'll probably go at the bottom of this as you scroll down. So mechanically, that's what's going on. Hey. Questions? No? Good. I think we've covered everything of any consequence. Yeah, that's it. Goodbye. Okay, moving on. So we begin. Peripheral nervous system. I'm not going to do all this stuff. You probably went through some of these. I'm just going to accent the part that I think is important for our purposes. Get this out of the way, and so I can see what's going on. Make sure my phone is shut off. Yeah, the usual. Sometimes we're doing things in the lab, and you're busy. That door slams, which you probably have noticed over time. So I tend to leave it open, and you come in and out. If you have to use the restroom, go ahead. If you have to take a phone call, take it out there or whatever. I don't care. I don't get excited about stuff like that, ever. So my wife yells at me, "You're always in a good mood." I am. Even the Steelers played better at the end of the season. I was happy. You guys are going to beat Baltimore, by the way, lady. Yeah, no, he's not going to play. Lamar's not going to. They can't throw the ball forward without him. Okay.
I was supposed to go, but we had.
Oh, really? You weren't? Were you at the game when he? I thought. Oh my God! I mean, my wife is not really a big football fan. It's like, what was that? Because we were watching something else, and I see the game was delayed, and I flipped it on. Because I'm watching on one screen, and I have my computer with the game over here. What are you doing? I'm just looking at this. I said, wait a minute. Flipped it on the big screen. It's like, oh my goodness. Oh, it was. Oh, I heard. Yay. Look, he's out of the hospital today, thank goodness. Look, that's it. And for everybody, that's one of the benefits. The good things are we become more aware of, firstly, the fleeting nature of life. You have to be, because you never, it's young, healthy individuals rarely consider their own mortality. Now, I realize it's a violent contact sport and things, but mostly we think of injuries, shoulders and knees and arms and things like that. But not thinking about cardiac events, but they made the illusion that, this has never happened in sports. They didn't watch the European Soccer Championships a year and a half earlier, where a guy who plays for my team now, for Manchester United, had a full-blown, and we'll go over that when we do the cardiac unit. He went into full-blown cardiac arrest right in the middle, and he went back and played the game later, which was a mistake, but after a couple of hours later, but I digress. Moving on, we don't want to talk to you. So, peripheral nervous system, everything that sticks out of the central nervous system. Central nervous system, brain and the spinal cord, period, done. Everything that protrudes or sticks out from it, And effectively, we divide them into two areas: sensory, afferent, the way you pronounce it, which is incoming signals, and efferent. You always make that distinction when you're speaking because it's too easy to say afferent and efferent sound too much alike. Anytime in medicine, particularly, and I realize not everybody's going into a nursing or a health related field, but that's who I have to share my information with. So we use, whenever you have words that can be confused, sometimes we partially spell, like a deduction and abduction, which you probably, like, you start to, you get it, it's all happens. So afferent and efferent. In the efferent division, things that go to the body, muscles and joints and things like that. And the autonomic nervous system, which we dealt with, most of you should have, in lecture, which is really controlling things that we don't control automatically, what we call autonomically. And that autonomic is divided into sympathetic and parasympathetic. Our focus point is mostly going to be in the somatic nervous system, sensory and motor. And so different kinds of sensation and how we interpret them. See, this is more, to me, and you'll see as I gloss over things, they are more likely things that I anticipate will be covered in lecture and are not important for us. And all these different kinds of receptors, okay? Things that are, whether from externally or internally. And as a reminder, and I touched on it for those who had me with autonomic nervous system, these are called proprioceptors. Proprioceptors are something that basically go to the cerebellum and give your mind the ability to know where your body is at any juncture. So all of you now, if you closed your eyes, would know, for those who you're sitting, maybe you have a pen or a pencil in your hand, maybe you're on a keyboard, you'd know exactly where it was. Those are proprioceptors, little sensors in different parts that tell you where your body is. Okay, and depending on how it's processed, and there's different levels that are there, and I don't get too excited about that. And we're not going to get into the signals in the field or how they're transduced and going into graded potentials and threshold. To me, that's more physiological. But we do have lots of these have the ability to adapt. It's just like in this room is a great example because it's constantly making noise. I always feel the need to speak loudly. But by and large, periodically, I don't hear it because the things like that are repetitive, to some extent, we tune out. It's like background noise. It's not always there. As a parent, you learn this right away. Okay? You don't want to hear your kids. I don't want to hear my kids. Oh, my daughter was on TV. She was at the game, the Steeler game on Sunday, and they panned to her. She goes, "Did you see me? Did you see me?" No, I missed it. I was very upset that I missed it. God bless. Different things. I don't think we need to do first, second, or third order. That has to do with sensory processing. By and large, they're sensed at one level. And then basically they go to, there's a 3-nerve circuit for the most part. And I covered that a little bit in spinal cord. And so these kinds of things, perceptual detection and magnitude estimation, not a big deal for us. Again, to me, that's more lecture related stuff. Pain is interesting. Again, more lecture related stuff. Impending damage. Pain is explained to me as a warning sign, for the most part. I mean, it's different if you've broken an arm or broken a leg, certainly. But in general, when pain, it's, at least initially, it suggests that there are problems, and it depends. A lot of things, typically it's chemical releases that are there. And there's a variety of tolerance issues to pain that aren't that much. A quick note about visceral and referred pain. Well, if you remember, in AP1, you probably looked at that homunculus, that sort of upside down character draped over the brain. It's very, very specific. If you go back and look for internal organs, there's not a lot. It's a very limited area. So when we see visceral pain, which means the internal organs, not a lot to it. It's very hard to isolate it. Where you know, if you stepped on something, you pretty much know exactly where it is. You know where that splinter is. But if you have a stomach ache, there's 10 people with a stomach ache, where there's a stomach ache, and they're going to point to 10 different places because it's very non-specific. There's a lot of things that cause it: chemical accumulation, blood supply issue. Spasms are very, very common, particularly in little kids. That's what colic is. Colic means a spasm. So oftentimes when there's significant pain, because there's other pathways that coincide with it and are close to it, we get this interesting phenomena called referred pain, because they travel in the same region and the brain is reading the pain, the intensity of the pain, and often misreads it as coming from, and the classic one, the internal portion of the left arm for a heart attack. If you get somebody, take me, if I walk in to the emergency room and say, I could have broken my arm, hopefully not, and said, I have left arm pain, you're going to look at somebody who's over 70 years old. I know it's hard to believe. This is an opportunity for all of you to go, oh, you couldn't be that old. Yet, no, you all sat there and didn't move a muscle. Thanks a lot. Somebody who's 70 years old, to be generous, could lose a few pounds, has had a long history of smoking in the past, on blood pressure medicines. The first 63 things they're worried about is a heart attack, even though your arm's cockeyed. Okay? That's the way it is. First thing you learn in an emergency room, address the thing that possibly could kill somebody. Rule that out first, because you have plenty of time to do the other stuff. First thing they tell you. Okay? So that's the classic example. A lot of times that could be indigestion. We've worked in the same way. Tightness in the chest, tightness in the throat, difficulty swallowing, all of those. If the person has enough appearance or background information, that's what you would look at. It's a wonderful chart about it. Okay, so here you can see along the neck, certainly, and obviously the left portion of the chest, the interior portion of the left upper extremity. Other ones that are classic, up here, lung and diaphragm. When the diaphragm is stretched, it goes up to the shoulder, typically the right shoulder. Where do we see that? If someone has a patient who is a lady and they're particularly having some type of laparoscopic procedure. Once you do laparoscopically, let's say you're going to do an ovarian procedure. You blow up, meaning you insert carbon dioxide typically in the interior through a scope and separate the organs so you can work on them. That puts pressure on the diaphragm, the first place you feel it. Little things like that. Typically, if you have pain in the inguinal area, groin pain, very acute, a lot of things you think of are bladder related, ureters all the way down here. What typically associated with that? Kidney stones. Just classic areas for this. And so physicians are well aware of these. Appendix pain radiating from roughly the area of the appendix much more centrally in the central abdomen. Things like phantom limb pain, okay? Because the circuits are still there even though the limb is not necessarily there. And there's a lot of ways that you can treat it. So when we classify receptors, we look at them as different things. We have ones that effectively are stretch receptors and touch receptors. They're mechanical. Something is pressing on them, pulling them, squeezing them. That's a mechanical receptor. Thermal heat receptors, like I told you, it's cold over here, at least I think it is. Photoreceptors, you're seeing with light. A ton of chemical receptors all over. So anything you taste or smell are basically chemicals that are dissolved in some way, shape, or form and are able to be sensed for whatever their properties are. And very specifically, what we call pain receptors are called nociceptors. I don't know what the derivation is. And again, then excessive heat and cold, chemicals. So you can stimulate a variety of these things. When they reach a certain critical point, our perception is pain. Pain's very interesting, very complex to understand. And to be fair, very difficult to treat. And a lot of errors have been made over the years, particularly in the last 30 or 40 years when a lot of people got addicted to opioids, when there was a lot of mistakes being made about understanding how addictive they were. Okay, and so that's all that type of stuff. So this is sort of the general business that you see around here. And anatomically, I don't particularly do this. I think this is more at a graduate level when you're talking about free nerve endings, whether it's just a nerve ending or whether they have some structure to them. And there's a lot of examples that you do not have to know. But a lot of times these free nerve endings, temperature, pain, light touch, the ones you see, we probably have more of these than any other. Okay, and this gives you some ideas of where they are. And for instance, you might remember there were Merkel cells that were part of the epithelia. They're about light touch that are there. There's a tiny nerve that sort of wraps around the base of a hair follicle. Again, more or less light touch. So there's not very specific. And they show you some examples of those. And then these encapsulated ones in more advanced anatomy, we talk about them because we understand them specifically, like Meissner's or Pacinian corpuscles. Okay, deep pressure and vibration, sensitive hairless areas, etc. Again, not a big deal. And whenever I say that, it's not saying I'm just giving it to you. Let's say out of a sense for completeness. That's there. These are interesting muscle spindles and organs and tendons. Those stretch receptors, typically when a muscle is stretched, it responds reflexively to contract. What we do as part of pre and post exercise are stretching exercises designed to be sort of simplify it, to overload those circuits. And then they're not as sensitive. And the theory is that people are less prone to muscle and tendon injuries if this is done. There's a lot of that has to do with sport medicine and conditioning. And if nothing else, you see this now all the time, early in the season, late in the season, early in the game, late in the game. There are certain times where we see an abundance of injuries. And I'm speaking more of injuries. The fact that event, cardiac event, happened early in the game is, I think, it's just such an unusual circumstance. So I can't comment on that. Which brings us to the eye, and that's really maybe the focal point for today will be a bit of the eye. 70% of your sensory receptors, half of the cerebral cortex, visual processing, yet only a sixth of that structure is effectively visible on the surface, which you and I can see when we're looking at each other in the eyes. The rest of it is mostly enclosed, surrounded by fatty tissue, surrounded by bone, in a structure called the orbit. And I'm sure at AP1, you all had to learn all the bones that are part of the orbit, the 4 facial bones and the 3, didn't you? 3 cranial bones, sphenoid, ethmoid, frontal, maxillary. I should be reminding people. So all of those things are part of it, and there are accessory structures in the eyeball, and we'll address that. So there's a very nice picture, lovely eye that you can see there. And I really don't care about palpebral fissures, the opening that's there, or a lateral or median commissure, sort of where it's on the nose side or on the away from the nose side, that is there, and eyelashes and eyebrows, and that's fine and dandy. Okay. I'm more interested in the important parts when we're looking at the eyeball itself. Question? Yes. Yeah, like I'd have a diagram like that. And when I print the diagrams, they either print without the lines or the lines don't have paper. Okay. So all I have to do is I put a line there, what's that? Without the openings called pupil, or what's that thing there? The iris. The white of the eye is called the sclera. So that would be, and typically a diagram you have 3 responses. And yes, there'd be a order thing.
I ever said that to one of my professors way back when, he'd go crazy. Yeah. Are we gonna have a study guide? I remember one of these guys in medical school said that to his professor who was 2 years older than God. God was in class with him. You know, studious kind of guy, beard even then. We call him. And then very serious. I'm joking, of course. I don't mean to be irreverent about those things. So the kid went up to him, I think it was Mark, he goes, Professor, could you tell him what could be on the test? Everything we studied from the first day of class to the last. Everything in your readings, everything in the lecture, everything in your notes. Turn around, notice the study guide. That kind of voice.
He was the world's leading expert on the anatomy of the lower extremity, and I was privileged to be in his last class at the time. He's long gone now. Just saying. So I move on. So again, those are the structures, major structures. The pupil is the opening. The iris is the pigmented area that's surrounded. It's surrounded then moreover by the sclera. The sclera is white, but you'll notice here, those little reddish areas. That's because there's a clear membrane that goes roughly from the exposed area to the start of the iris and covers the white of the eye. Famously, it's called the conjunctiva or conjunctiva. It's clear except when it's irritated. You could irritate it from rubbing it or by an infection. And when it's irritated, it becomes inflamed and the blood vessels increase with the amount of blood. And what happens? They become visible against a white background. So, for not that you guys would ever do this, is where the term bloodshot comes from people who have been perhaps indulging themselves too heavily in certain alcoholic beverages, which I know none of you would be inclined to do. Right this instant. Riley's looking at me going, yeah, last night though was different. Well, I know. When my daughter buys the bar, I'll let you know where it is. They're talking about buying a bar. Seeing her fiance, the guy who graduated from university. And so that's now what covers this area. The iris and the pupil, very famously, is another clear piece of material that's actually very similar to the white of the eye, except the fibers are arranged differently, and that is called the cornea. You'll see that in subsequent illustrations. So what this is going to be is sort of your introduction to some of the things you started to see already. Remember we did muscles and nerves, or you did them, whoever did AMP1 with you. You had epimysium and perimysium and endomysium, those kinds of things, epineurium, perineurium, and endoneurium. Well, what you have as a recurrent theme, layers of three. And the eye, and I should have an eye someplace right here. It's not a whole lot different. So, and it's not bad. Sweet. But you have three layers. You have, they're called tunics. The fibrous tunic, which is the sclera, and then the clear zone of the cornea, again covering the pigmented area. Then you have a highly pigmented vascular area. Okay, so that's the tunica vascularis, and then deep to it, you have the tunica nervosa, which is mostly the retina. Then you're going to see some extensions that create and develop a relatively large structure in the eye that allows us to focus called the lenses. And that's the construct. So get used to seeing lots of layers of three anatomically. You'll see them respiratorily, you'll see them in blood vessels, you'll see them in urinary structures. Digestive is interesting because it really has a fourth layer, and it's more about the complexity of the innermost layer because we're digesting and absorbing our food and nutrients. That's sort of the oddball. And it's not, and it really is just sort of a more extensive internal layer that's really divided into two, might be a way to look at it. So as we move on, again, eyebrows and eyelids don't care. Conjunctiva, I care. Lacrimal apparatus, tears. And what you'll see in the subsequent illustration, the analogy for your tears, for the lacrimal apparatus, and then the duct, the apparatus is sort of in the upper outer area, and the lacrimal duct, you remember that lacrimal bone, that little lacrimal caruncle, that you get that bump on the nose portion of your eye, there's a little duct that goes into your nasal cavity. Interestingly, for those in micro, you might end up seeing that that's one of the pathways for infection. Because not all conjunctivitis comes from rubbing your eyes, or even though with little kids it does, but that's sort of an opening into the nasal cavity, so you get infections going in both directions. But the lacrimal apparatus is kind of like in your car when you have like the spritzer and you have one on the top, like maybe if you have a car with a back wiper, and it spritzes down and the wiper distributes it. Kind of your lacrimal apparatus works like that. And then the eye has what are called intrinsic eye muscles, which I must tell you about. So eyebrows, yeah, shade, prevent perspiration, all by that. Fissures and commissures and the caruncle and tarsal plates, and and the different musculature. I'm not really into that. I want to talk about the eye. They blink a great deal. The eyelashes certainly play a role with that. Certain amount of lubrication is part of that as well. And that's not a bad illustration. Kind of gives you the idea that here you can sort of detect that clear layer of cornea and then a little more adherence. You can begin to see the sclera, but they are continuous, except one's clear and one's not. What's interesting, in order to keep that clear and the tissues are similar, when you're alive, you have pumps that move ions, charged particles that allow that process to occur. When we die, it clouds over. So when you look at the sheep's eye and you see the cornea, it's clouded over. That's why if you see somebody in repose, somebody who's died, they generally have their eyes closed because the family gets a little disconcerted, when great grandpa is, got funny looking eyes. Do you guys see Wednesday on Netflix? Oh, it knows. All I can think of in the Addams Family is how she would sleep. Oh, she was great. Wow, talk about a star is born in that show. And they had the lady who played who was from Game of Thrones in that, played like the principal, a very tall blonde lady. She was from Game of Thrones. She had a great part in that. Nevertheless, moving on. So you can sort of see that the way it is, they have these little pockets, and that's somewhat consistent. We see that in joints as well. That sort of way the soft tissues are arranged, that are there, styes and infections. So the conjunctiva, transparent mucous membrane, lubricating in nature, different parts of it that are there. Conjunctivitis is something you probably will address in micro, what we call pink eye, because when it swells and the blood vessels are prominent against the white background, pink in color. If you haven't had it, be thankful. The lacrimal gland, and I'll show you, this is what I mean. It's almost like here's the secretions, and as you blink, it kind of is sort of just like a windshield wiper going across, and it begins to drain into this area, which goes into the nasal cavity. So I think that illustration sort of serves its purpose that way. I don't know if you all did the extrinsic eye muscles. Am I ringing a bell? Did you do cranial nerves? People with me did cranial nerves. Okay. Well, the cranial nerves, the third, fourth, and sixth cranial nerves are the nerves, and we'll go over them. That allow you to move your eyes up and down, side to side. Sort of that, follow my finger kind of thing. You know what I'm talking about? Thank goodness. This is the Horowitz brothers.
from the Lower East Side of New York. Yeah, Jerome and Morris, all in Crow. Sweet. Sweet. I have a three. I used to wear ties. I used to. My wife doesn't like to wear because she was not used to. So it's so here we have an eye. Here we have a nose. My artwork. We have 6 muscles. And I'll do this again when we do the cranial nerves. 4 of those muscles on the eye, you start to see some areas where they're trying to point to things here and here. They are straight muscle, and when the muscle is straight, we name it rectus. So you have the superior rectus, the lateral rectus, I'll just put that, inferior rectus, and the medial rectus. You have 2 other muscles that come at an angle. Because they're at an angle, we call them oblique. So the oblique muscles in your abdomen, whose vertebrae, scrotal muscles, and when they're damaged, it's tough. Pictures damage from baseball sometimes. The superior oblique and inferior oblique. Those are the 6 muscles. They're innervated by the 3rd, 4th, and 6th cranial nerves. Down the road, you'll see when we for those getting the cranial nerves again, we use this formula. It's like a chemistry formula, but it's not chemistry. LR6, SO4, 3. SO4 is not mean sulfate. That's the chemistry. Lateral rectus is innervated by the 6th cranial nerve, superior oblique by the 4th, and all the rest by the 3rd. If you remember that, you never get a question wrong. Ever. Ever. You see that all those nerves, I remember the superior orbital fissure of the orbit, they go through that, and they all are innervate the extraocular muscles. So they're part of the discussion when we do the eye. Because that's one of the ways we assess whether or not there's been a problem vis-a-vis eye function. And I'll give you more about that because not today, but we'll probably do cranial nerves next time. Okie doke. So that's what they're describing. And there they are. Better drawing than I have. And all the same names and everything else. And here you can see the oblique muscle. So when it pulls, it's going to rotate the eye sort of downward and to the side, and the other one will, go in the opposite direction. Voila, here's the inferior oblique. That'll rotate it around and bring it, almost like rotate the interior portion upward like that. And they give you all the ones. And again, I'll go over that again when the time comes. And so when they don't go together, you get diplopia, which is double vision. Okay? And there's a lot of things that can lead to that. Some people are born with weaknesses. One of my sons has that, where his just got, so they used to call it like a lazy eye, but it's never really affected him whatsoever. He's very good in sport. It's like that. So that's when you see this sort of cross eye or congenital weakness. And sometimes, in very severe cases, you have to do some type of surgical remedy, which brings us to this triple layer effect that are there. The outer layer, and the old days they called them tunics, but layer is fine, fibrous, vascular, and inner. In the old days, fluids were called humors. So when someone was in an ill humor, they had, back in ancient, not ancient, but maybe in almost, let's say, Elizabethan times, when they were bilious or sanguinous, okay? And what they used to do was they would bleed people. They didn't know any better. And they thought that because it was swollen, we would bleed them, it would be less swollen. But all that aside, humors were another term for fluids. So there are 2 sets of fluids that are separated, and I'll show you that in the eye in a bit. The thing that separates the anterior, which is about 1/6 of the volume of the eye. Think of it as, a globe, and that lens is situated such that the anterior portion of the globe is about 1/6 of the volume. The posterior portion is about 5/6. Here it is. Here, and you'll see this on the dissection beautifully.
you'll get one that you can see all of these layers. That's why I like the dissection. So here is the lens, which looks like a little nugget, and then normally it's clear, but obviously when they've dissected out an eye out of a dead sheep, that has clouded over and appears much thicker. It has little strands, and those strands are called suspensory ligaments, and you will see remnants of them because the material is pigmented on the lens and hanging down from this, which is called the ciliary body or ciliary ganglia. It is tied to the muscle, and if you remember, the muscle is the orbicularis oculi, a circular muscle. And that muscle, when it opens and closes your eye, there's also, we have a similar effect that occurs by way of the ciliary ganglia. And what it happens when it opens, okay, like that, what it will do is it will cause a certain amount of stretch. And what that will lead to is dilation of the pupil. They will widen. And when the pupils widen, we use that for vision, for wide vision, for seeing objects far away, for distant vision. So if you look up and look at me, your eyes widen. If you're sitting there looking at a computer screen or where you're making notes, it's narrow vision. Your pupils constrict. So what happens when your pupils dilate, it sort of opens up and they stretch that lens so the lens flattens, and it allows the light to be basically, and the term we use is just like you learn about with a microscope, is refracted. It angles the light so it goes to where most of your vision, which is not here. That's called the optic disc. That's the blind spot. You want the light to go here to the fovea centralis. That's the area of the macula. And most of you will have heard about something called macular degeneration. That is where your maximum vision is located. So when you're doing close work, let's say you got a message, you're looking on your phone, you're typing something in. Okay, now the whole thing changes. Your pupils constrict. This narrows. What happens? There's less tension. The lens is not nearly as flat. It changes the angulation, and so they're all together. And I'll do that when we do the cranial nerves once again. So that lens, there's fluid here. It's called aqueous in the anterior segment, or aqueous humor. That fluid is produced and drains throughout, continuously produced, and you make more of it, and what's there drains. If it does not drain sufficiently, normally the problem, or if there's too much made, less so the problem, it creates excessive pressure against the lens. And it creates a very painful condition that can lead to blindness. That's very famous, called glaucoma. And so for any of you who have had your eyes tested now, they used to put a device on it and measure the pressure. Now you have a device that kind of does all the things when you're getting your eyes checked for whether contacts or glasses. So the last time, and they'll do all of these things simultaneously. Okay? And so whether you're at an age where they test for glaucoma, I don't know. Thankfully, glaucoma is fairly easily treated with drops and sometimes with medicines. That was my best friend tells me that because his wife was just diagnosed, she's about 66, and they knew she had that tendency. That was one of the early reasons why they legalized marijuana, to reduce glaucoma. I think that was just an excuse. It's a long story. I started college in 1969, right after Woodstock. It was a famous rock concert, these many years ago. I know. Don't start. Don't start. It's like when my daughter was dating this guy who was my age. So that's a whole other story. Not for me. He and I had a lot in common. For her, no. But I turned to her and go, he's got clothes older than you. We had a lot of money. Sugar, dating. And you think you've put your parents through a lot. I'm a pro. You have no idea.
So how did she write that?
Are you asking that just out of curiosity, or are you looking for the website address?
Both.
Both. I'll ask her. I'll ask her. And she's my daughter's great. She's good like that. Of all my kids, she is the nicest. She just is. Everybody loves her. Don't start. You're awful. You're terrible, all of you. Okay, moving on. So again, the external layer is the sclera, continuous with the cornea, which is clear. Then you have the fluid filled called the aqueous humor. So that's constantly replaced. Behind the lens, about 5-6, there's a rather substantial gel-like portion called vitreous humor. It's sequestered. You're born with it, okay? And it really maintains the shape of the eye, for lack of a better way to describe it. Very often, post-mortem, that's analyzed for drugs or substances and things. Like you can get a lot of ideas for cause of death from sampling vitreous. It's nothing you would ever do when someone's alive. Okay, that's the outer layer. The next layer is this pigmented layer, sometimes called the choroid or vascular layer. And effectively, that pigmentation prevents light from scattering. When light enters through the opening of the iris and it goes through, the light is going to obviously trigger the neurosensitive area known as the retina here, which is not nearly as thick as it's depicted. But the sensory part where you actually see is right against this pigmented area. It prevents the light from scattering. Before we had digital pictures, which we all are familiar with, if you see somebody with older cameras and film, okay, when you got that film and you took it to be developed, you did it in a dark room. Or if they had trouble getting the film out of your camera, they had like a little black bag that they would get, at the photo store or wherever you had your photos done, like in a grocery store or Target. Someone could extract that without exposing it. That's kind of the idea. And that pigmented layer continues to make that ciliary body. It continues to make the pigmented portion of your eye, the iris, and the opening in it that's controlled by that ciliary body is the pupil. They're all technically part of that middle or vascular layer. The internal layer is the one you do mostly in physiology. We call it the retina. As you can see, remember, this is a sensory body, so the nerves go out. The sensors are here, and they lead toward the brain that way, through the optic nerve. So where the nerve enters or exits, if you will, there are no sensors. That's why they call that the blind spot. You will see that on the dissection or be able to approximate it. But the highest concentration of cones, C-O-N-E, which are the ones that are the most light sensitive and give you color. CO for cone, CO for color. Can't miss it. You have 20 or more times more rods, which are for black and white. They're more concentrated peripherally. That's why at night you catch a deer running out of the corner of your eye, but you might all of a sudden you're driving and you see one right in front of you. And if you're from around here, it happens too frequently. How the hell did that get there? I have a deer warning system in my car. It barks. He barks. It's a very big dog, as many of you know. Lincoln the dog. So sclera and cornea anchors the extrinsic muscles, optic nerve exit. Sclera is continuous with the dura. You remember that from AP1. The cornea, transparent, clear window that's there. A lot of pain receptors, blinking. Vascular layer, some people call it the uvea, I don't. The choroid, which surrounds most of the eyeball. Ciliary body and iris anteriorly. Again, prevents the scattering of the light. And there's a ring that really holds the lens with the so-called ciliary muscles. Those are the muscles that act like the sphincteric muscles that open and close, similar to that orbicularis oculi. And then you'll actually see evidence of those suspensory ligaments, the pupil, close versus distant vision. And obviously they change with other things, the emotional aspect, fight or flight, which many of us, which my students learned about in A&P. And there's that same illustration. So what happens, and this is one of the big tells with sympathetic and parasympathetic. When parasympathetic stimulus, let's say an opiate overdose, eyes are very constricted. With a speed overdose, cocaine overdose, the sympathetics are overloaded and the eyes are very dilated. And it's a very useful tell in an emergency room. And here's the retina, millions of photoreceptors, glial cells that support it, has the outer pigmented layer that's adjacent to that choroid layer for scatter, and actually the nerve processing is a bit more interior. And that's something that you'll look at that's there. And it plays it's a big role with vitamin A. I don't want to get into it because I think that's more lecture material. Okay, that these cells, we constantly produce them. They fragment when they've been exposed. We gobble them up and make more. It's continuous. That's one of the neat things when there's a big light and most of us, we get temporarily blinded, but it's just for a fraction of a second. In a dark room, somebody flips the light switch on, and it's very uncomfortable. Well, that can even happen. So for years, one of the best treatment was they would just, for like 2 days, not let anybody see anything in the hopes that when they removed those eye coverings and did not allow any exposure to light, that this healing process would ensue and all of these new photoreceptor materials would be produced. And you'll actually see this little serrated edge on the interior portion very distinctly in the eye. And then the cellular to me is all physiology, and I'm just about done talking with rods and cones. One more thing, that's the best sensory area, that macula lutea, the most cones. The fovea is the little pit. That's really where your glasses go to. You'll get into that, I think, from a lab. And this is the last thing. Now they do this higher technology things when you have your eyes checked. This is one of the rare areas and in the old days we used to do it with an ophthalmoscope. Maybe they still do. And in nursing, many of you will probably have an idea. It's not easy to do. Most time you have to dilate the eyes. You're new at it. Not ophthalmologists, so you should do it. But nowadays, again, we have the technology. Those are actually arterioles. It's one of the few areas where you can visualize with just a relatively simple device an actual arteriole, a tiny, tiny artery. So it's a way, what happens here is happening at the other arteries. So you would check what we used to call the eye grounds, that to actually see if there was obstruction, if somebody had heart disease. So if you don't know, I was a very heavy smoker for 40 years. And my doctor, I remember years ago, looking at me and goes, "You haven't seen some changes in your eyes." And then about 10 years after I stopped with that, 14 years, 14 years. And then since then, when I had my eyes checked, I had an eye doctor look at me and go, "You were a smoker, but you're better." If you didn't know, I smoked for 40 years, 2 packs. That's a lot of smoking. Yeah, that's a damn. It's okay. I came from a household of smokers. All right, and detached retina and all that. That's all we're doing. Okay, moving on. Are you ready? Okay, I'll show you. I can show you here and I can show you there. This is kind of what this eye work stuff looks like. I can just show you what somebody's from a student previously did. When you look at it, if you look at this, you're going to say okay to IXTA. And even though this isn't there, you're going to say okay to that. And what will come up is this. This is a test using the lab scribe. And what it did, those little black lines were generated when I pushed a button. And what they did was it created a black line. Then the student, whoever was the subject of the evaluation, wherever I put that thing that I'm going to test with, of course I don't know what it is. It'll be here. That's not it. Help. I'll find it. Ah, here it is. This is just like a button that the person would push. And so all I had to do was plug that in. And when I would push the button, when they saw the black line, they would push it. Or they heard a sound and they would push it. And then it would generate a response. So this was, I had combined these different things. And what you can do is you can move these little cursors, these red lines. Here's where the sound was. And I moved it this way to where they responded to the sound. So this would be T1 and T2. Doesn't matter what order. And so you could begin to look at the distinction. 500 milliseconds, a half a second to respond. And so what we were doing is we were testing visual versus auditory responses. So they would be standing here and they'd be watching this scroll and they'd see a black line and boom, they'd have to hit the button. And so the question was, then I would have them redo the same experiment, and rather than see the black line, I would hit the button, but they would not just be looking at the button, all they would be doing was hearing the sound of my voice. I have them close their eyes. And I'd say, go, go, go. And every time they heard the word go, and you don't do it the same interval. So it'd be like, go, and then you might say, go, go, and then go. So you alter the interval, and over maybe 10 different sets, create an average. So which one do you think a person would respond faster to? Visually seeing that black line or hearing the sound? There's no right or wrong answer. Would you be faster seeing it or hearing it? We'll do it this way. All those in favor of I'll be faster seeing it, signify by raising your hand. All those, thank you. We have people responding. All those by hearing it would be faster. We have other people responding. It's okay. Be happy I'm not having to hold up a little card. One of my colleagues does that. How many of you guys think it's A? How many think it's B? You're awful. All right. So that's kind of the experiment that we're trying to do. Let's see if we can make this work. So I'll have to figure this out. Give me a chance. So see if I can get someone up here to test. Now, I'm doing this more. I don't know if I don't really have it set up to do. So hold on. Let me try it this way. So I have one here. So it's too hard. I mean, I'd have to show it to you. But this particular student, we did this, and I mean, obviously, from you folks sitting back here, and what I have to do is, and that's the problem with this particular room. I don't only have the plug here, and I have to bring in extension cords and things like that. So, but I just wanted to give you an idea what this system does. So what happens is I have the red on a black line here, and this was auditory, and she responded in about 240 milliseconds, about a quarter of a second on average. Okay. And then I had the same student. and then this was from 2 years ago when these two gals, and then it's interesting, they're both working, either going for med school or PA school, physician's assistant school, over, and I ran into them a couple of months ago over at North Hills Pascan Hospital, where they're both working over there now, like taking a gap year and getting ready. So now on the next one of these, this was the visual, same person, so it should be fairly accurate. So it was a quarter of a second to respond. For that, it was more than double visually. For those people who thought auditory was faster, typically that's the case. So you're closing your eyes, you're not getting any visual signals, and you hear me say, or whoever is doing the testing, going, go, and you hit it like that. Now, when you're looking at something, you basically, your brain is seeing this line come out of nowhere, and then you respond. It takes this finite amount of time for that process here without being sort of confused by the visual nature. Boom. Okay. Just relying on hearing, the response is very, very quick. Interestingly, it takes a little bit longer to see the line and press the button rather than just hear it. It's almost like you're taking there's a finite amount of time that's involved. So I don't know if you could see it, but I can send you that just so you can, and I'll do that and send those to you separately. So what happens from here, see, I don't have any recording hardware connected with that. So normally I would just press the record button and this would scroll and we could do something with it. So I can't do that even here if I open a new one. Maybe, see again, without the recording hardware, and I tried to hook up the hardware to this computer, it wouldn't take it. So normally what I have to do is bring my laptop in, set everything up, and then get the connector to hook the laptop into the screen, which takes a little bit of doing. So I'm not going to do that today. Okay. So I wanted to acquaint you with that. I'll send it. You can just look at it. You don't have to write anything about it. So you can just take a look at so I have these two students who both did this, and you can sort of compare and contrast and see how it works, just to give you an idea. So there's a lot of things you can do with these. These will alter the displays. It'll double it. It'll make them farther apart or closer together. Okay. This auto scale, sometimes the responses will be way off the chart. It'll bring them in closer together. So there's a lot of different things that you can do with this to make it easier to see. And so you'll find it more useful when we do nerve muscle testing, which we're going to do a little bit of. Because you all had muscles before, and I'll probably set that up for next time when we come in here, and I'll do that. So I think that's going to be everything from listening to me talk for an hour and 15 minutes. Now that my voice is going to die. And so we did the eye. Next time I think we're going to do the ear, and we'll do a little bit more of that stuff. And I'll probably try to get in the cranial nerves, and we should be all set for the eye dissection the following week. So we do meet next week, because Monday labs, obviously because of MLK Day, weren't going to be on. But your lab will be here. Right. So thanks a lot, everybody.